All right, in this video, I will be going over a quick review of some important problems that you will see um, for our first exam for class. So I'm going to be going over some of the most important problems for the course, at least for this exam. So one of the first things that we discussed in this class was the idea of a limit. So for example, let's say somebody tells you to find the limit as of the following: of g of t is equal to t minus 64 divided by square root of t minus 8. Square root of t minus 8. Now, let's say somebody asked you to find what the limit is as t goes to, let's say, 64. So somebody tells you, find limit as t goes to 64 of g of t. And they told you to use a table to estimate it. Clearly, we cannot plug in. And the reason why we cannot plug in is because we're going to get indeterminate form. If you plug in 64 for t, you get 64 minus 64 divided by the square root of 64 minus 8. That's equal to 0 minus 8, which is 0 over 0, which is indeterminate. So we cannot use the plug-in method. We must actually do some estimations. So the way that I will do this, that I would suggest you do this, is to make a table. You have your t values and you have your output values for g of t. And pick numbers very close to 64. So, for instance, you don't want to start with 0. You start with something like 63, 65, 63.999. Let me move this down a little more. 64.001, and so on. Let's say 63.9999 and 64.0001. Right, you want to do something like this. So if you begin with 63, that's going to be 63 minus 64 divided by the square root of 63 minus 64. On your actual minus 8. On your actual exam, I'm going to try not to give you numbers like this. Although you're allowed a calculator, which is completely fine. And you have plenty of time to compute this. So it's going to be minus 1 over, let's see, the square root of 63 should be between, roughly 7.9. So let's just say it's 7.9. I'll just round to the nearest tenth. So 7.9 minus 8, so that's minus 1 divided by minus 0.1. And minus 1 divided by minus 0.1, 0.1, is equal to 10. Okay, so we have for the first one, 10. Now let's say we continue on with 63.99. So if you have 63.999 minus 64 divided by the square root of 63.999 minus 8, well, what do we have here? Well, the numerator is going to be minus 0.001, right? And then the denominator is going to be equal to, let's see, what is the square root of 63.999? So that's 7.9 again. I'm just rounding to the nearest tenth for the denominator. If you want it more accurate, it's going to be 0.999. Right to the square root. 7.9999. and then minus 8. So this is going to be equal to minus 0.001 divided by, again, minus 0.001, which just looks like this is 1. Let's see. That looks like 1 to my eyes. And then if you go the other route, 65 minus 64 divided by square root of 65 minus 8. Then what we have here is 1 divided by 8.06 basically, minus 8, which is 1 over just 0.06, and 1 divided by 0.06 should be 6. And now, actually 16 by 6 is 166. And now if you move to the next one, let's say 64.001 minus 64 divided by the square root of 64.001 minus 8. Then we have in the top 0.001 divided by, so let's see what's the square root of 64.001 is. It's going to be very close to 8. It's actually very close to 8. It's 8.000062 minus 8. So it's equal to 0.001 divided by 0.000062. And if you divide 0.01 by 0.000062, you get 16. Which means that I have a mistake up here. Yeah, it looks like I have a mistake somewhere. Let's see, is this actually correct? So if I have square root of 63.999, that's 7.999. If I take away 8, it's actually a very small number. Yeah, it's a very small number. So if I take away 8 from this, it's actually not this. It's going to be negative 0.000062, which means it's not equal to 1, but it's actually equal to, let's see, 0.001 divided by 0.000062. Yeah, there we go. This makes more sense. 16.12. So now we can see that the limit is actually approaching to being 16. So we could say that as t goes to 64, the limit is 16. So limit as t goes to 64 of t minus 64 divided by square root of t minus 8 is equal to 16. So on your exam, you will have a problem like this where you will have to find the limit by estimating what the limit is. Okay, so that's that will be one of the problems on your exam. Another problem that you will have on your exam is finding the limit of a graph. So given a graph, you'll be asked to find the limit of that particular graph. So let's say if you have something like this, where it goes like this. Let's see. Let's say we have a point here. Then, I may ask you, let's say this is 3, let's say this is 5. I may ask you to find, let's call this function h of x. I could ask you, what is the limit as h of x as x goes to 3. I could ask you what is the limit as x goes to 5 from the right side, let's say, of h of x, or from the left side, I could ask you what is the limit as x goes to 0 from the right. Let me change this one from the left side. Left side, so this one from the right side of h of x. I could ask you what is h of 3, let's say, if I give you the value up here. Let's say this is 6, and let's say this is 4. and I could ask you what is simply h of 3. And based on the graph, you should be able to determine what these things are. So if somebody asks you what is the limit as h goes to x from the left and right side, then you know that you'll follow the lines from the left and right side, and the limit here is 4, but h of 3 is actually 6. So the limit here is 4, but the h of 6 is actually 6. And to find this one, you really have to do what we did before. You really have to find values very, very close to it from the left and the right side. If you're looking for the limit of 5 from the left side, it's simply moving on this direction. So you will have a problem like this where I ask you to find the limit given a graph. I think that's a pretty neat problem, and it's definitely a problem that you should be able to do. Same thing for a piecewise function. So if I give you a piecewise function, like for example, h of x equals 0 if x is less than 0 and 1 if x is bigger than or equal to 0, then you should be able to find the left and right limits as you approach 0, and you should be able to actually find whether or not the limit exists. So if you graph this, I'm saying that to the left of 0, when x is negative, I'm 0. So I'm saying that this graph is the open circle there, and then the x-axis. And then the x-axis. That's the top one. And then the bottom one is going to be equal to 1 when x is 0 or positive. So it goes in this direction. So if somebody told you to find the limit as x goes to 0 from the right side of h of x, then you could clearly tell them that as you move in this direction from the right side, the limit is 1. And if you're moving from the left, limit as x goes to 0 from the left of h of x is equal to 0. Clearly, the limit from the right side is not equal to the limit from the left side of h of x. So therefore, by definition of a limit, the limit as x goes to 0 of h of x does not exist. So if the limit from the left side and the limit from the right side are not equal, then the limit does not exist. Okay, so these are the type of problems that you should expect to see on your first exam. These are problems that we cover for sure on homework. Okay, so this is another type of example that you will definitely be asked to solve. What if somebody gives you the limit of 5 as x goes to 4? Well, there are no x's to plug in here. The limit of 5, the limit of any constant is just the constant itself. So the limit of 5 as x goes to 4 is 5. If you plot y equals 5, the line y equals 5, is a horizontal line. Graph of y equals 5 is a horizontal line that goes through 5. So if you go all the way out to 4 on the x-axis, you could clearly see that you're going to be hitting up here, and then when you take the limit from the left and the limit from the right, you still get the value 5 because the output here is 5. So the limit is 5. So that's a simple problem that you may or may not have, so you definitely need to know how to do them. You never know what I'll put in. What about a more challenging problem? What about this one? What about limit as x goes to minus 2 of 5x squared plus 8x minus 4 divided by 6x minus 6? Now this is a rational expression, and we're taking the limit as x goes to minus 2. if, and this is something important, if the denominator is continuous, like in this case it is, and there are no holes by plugging in -2, then we simply substitute. We use direct substitution. So we can actually plug in for whatever we see an x, we can plug in -2 and take the limit that way. So we plug in wherever we see an x, we plug in -2, and we can actually figure out what the limit is. So the limit as x goes to -2 is equal to 5 times 4 minus 16 minus 4 divided by -12 minus 6. But notice that the numerator is going to be 0, so this whole limit is going to be 0 because 5 times 4 is 20, minus 20, and divided by minus 18 is just going to be 0 because the numerator is 0, so the whole thing is actually 0. So you definitely need to be able to use direct substitution to evaluate a limit analytically. Let's do another one, more challenging one. What about the limit as h goes to 0 of 1 over 3 plus h minus 1 over 3 divided by h? Here, notice that direct substitution is not going to work. And the reason why it's not going to work is because when you plug in 0 for the limit, we're going to get undefined. So we cannot do that. So what that means is that we have to simplify the rational expression by first rewriting it. So what I will do is, let's try to first combine the numerator and then deal with the denominator. So if I combine the numerator, notice that here I have to make the denominators equal, so I have to multiply by 3 over 3 on this side and by 3 plus h divided by 3 plus h on the right side if I want to make them equal. So what I'll have is 3 minus h on the top divided by 3 times 3 plus h in the bottom. Now 3 minus 3 is going to cancel, so I have, and this is all divided by h, so I have minus h over 3 times 3 plus h over h. And now, and I'm still taking the limit, so now if I have limit as h goes to 0 of minus h over 3 times 3 plus h, and instead of dividing by h, I'm going to multiply by the reciprocal, which is 1 over h. Notice here that the h's are going to cancel out, so I'm left with the limit. I'm left with limit as of -1 over, and now I could actually multiply in, it's fine. 3 times 3 is 9, and then 3 times h is 3h. And now notice that if I plug in 0 for this, if you take the limit and you plug in 0, you're going to get that the limit is equal to -1 over 9. So the limit as h goes to 0 of this expression is -1 over 9. So here the challenge is understanding that when the direct substitution method doesn't always work right away. You have to sometimes rewrite the expression in order to make progress. So we first rewrote it so that there is no h's in the denominator, and then after we have rewritten the problem, we try direct substitution again until it works. Sometimes it just doesn't work, and sometimes you have to rewrite it. So you may have a problem where you do have to rewrite the denominator. Now, I will give you a problem, and this is something that you will have. What number was this? This was 3? 4. So I will give you a problem where you have to find the limit, one of the special limits, either limit as x goes to 0 or of sine x over x, or something like limit as x goes to 0 of cosine of x minus 1 divided by x. Meaning if I gave you something like this, and I gave you what they're equal to, which we discussed this in class using the squeeze theorem, you need to be able to use this to take the limit of something like this, like limit as x goes to 0 of let's say tangent of 8x divided by sine of 2x. Now, this may look challenging, but if you understand what you're doing, then you shouldn't have much trouble with this. Okay, so remember, tangent is the same thing as sine over cosine, so you could rewrite this top piece as limit as x goes to 0 of sine of 8x divided by cosine of 8x, all divided by sine of 2x. Now, you will have to rewrite the sine of 2x, and you will have to be clever about rewriting this 8x on the inside. So if you remember from whatchamacallit, actually we could even rearrange this. We don't have to do that. If we first rearrange this, let's see what we have. So we have sine divided by sine. So I could rewrite this as limit as x goes to 0 of sine of 8x divided by sine of 2x, which will make our lives much easier, times 1 over cosine of 8x. I'm allowed to do this. We're allowed to actually do this. Because both of these are being divided by sine of 2x. So we can actually do that. And if we do this, then what happens? Well, now we can actually take the limit as x goes to 0 of both of them. And we could actually, let's see, can we plug in 0 here? Oh, of course, yeah. Yeah, I could do this. So here we have limit of sine of 8x over sine of 2x. So we can actually rewrite this as limit as x goes to 0. I'm allowed to multiply and divide by the same thing. So I'm allowed to multiply by 1. 1 here in this case is 8x over 8x. That's equal to 1. So I could do this. I could do 8x times sine of 8x divided by 8x divided by, and I'm going to do the same thing with the denominator. I'm going to multiply by 2x over 2x. So divided by 2x sine of 2x over 2x. And this particular limit, so what I'm doing here, I'm taking the limit piece by piece. So if you don't recall, we could take the limit of a product by just taking the limit of the first piece and then multiplying it by the limit of the second piece. So because of the rule of sine and cosine, especially for this rule, I gave you that sine of x over x equal to 1, then that means that I have the following. We could pull out a 8 from here to the outside, 8x. And then what I will have is sine of 8x over 8x. And then in the bottom I have 2x times sine of 2x over 2x. And now, because of this rule, this piece and this piece will become 1. So I'm left with 8x over 2x times 1 over 1, which is simply equal to the x's cancel out, and 8 divided by 2 is 4. So I'm left with 4 in the first expression right here. And then I could do the same thing for the second expression. I have limit, for the second expression I have limit as x goes to 0 of 1 over cosine of x. Now, if you plug in 0 for cosine of x, then you just get 1. You could actually just do the plug-in method here. So 1 over cosine of 0 is equal to 1 over 1, which is 1. And 4 times 1 now, so you have limit as x goes to 0 of 4 times 1 is 4. Well, let me just rewrite this. Limit as sine 8x over sine of 2x times 1 over cosine of 8x. It doesn't matter that the cosine is an 8x because you just plug it in 0, so everything's going to be 1. It's going to be 4 times 1, which is 4. So the limit is 4. Okay, so you have a problem where you have to use one of these rules, either the sine rule or the cosine rule. So you'll be given this piece, however. You'll be given what they're equal to, and you will have to cleverly use this these rules to rewrite the problem. So, for example, the other rule is cosine x minus 1 over x. That's equal to 0, right? That's what I have up here. Yeah. So, you know, if you're given a problem where you have, I don't know, let's say you have somewhere where you have like 5x cosine of x minus, let's say, 5x. Then you know that you could factor this 5x out. So you could say 5x, you know, cosine of x minus 1. And then you could multiply top and bottom by x. So you can multiply this by x. So you have 5x squared times cosine of x minus 1 divided by x. But then now you could separate them. So you could now write, and you know, this is obviously as you're taking the limit as x goes to 0. Now you have 5x squared over x times cosine x minus 1 over x. This is going to be 0 by the definition given above. And then when you multiply 0 times this, that's also going to be 0. And you're good to go. So that will be the solution for a problem involving cosine. You also need to remember what the squeeze theorem says. So the squeeze theorem says, or the sandwich theorem says, that if you have a function, let's say you have a function like this, like that. And then let's say you have another function that goes like this. Right? And let's say you have a third function, and this third function goes like this. Goes pretty big, like this, like that. So let's call this 1, 2, and 3. The squeeze theorem says that if you know that the limit as x goes to a number, in this case I'm going to say 0, of the first function is equal to the limit as x goes to the same number for the third function. And if you know that the functions are trapped, meaning the second function is trapped between the first and the third, then the limit of the second function at that point, at 0, has to be the same as the limit of the first and the third function. It also has to be 0 for this particular point. So you definitely need to review the squeeze theorem. We covered that earlier in the course, and the concept itself will be used in the background. You will not have to evaluate a limit using the squeeze theorem, but you should understand that the concept is always lurking. It's always going to be around you when you take a derivative. And it could help you out when taking derivatives as well. You also will have to find limits at infinity and infinite limits. Okay, so if somebody gives you, for example, this is x. If somebody tells you find the limit as x goes to infinity of something like x cubed plus 5x plus 5 divided by 3x to the 2 plus 4x, then you have to be able to find this limit at infinity. So what's one strategy that you could use? Clearly, you cannot use direct substitution. Why not? Because you're not plugging in a number. To use direct substitution, you have to be plugging in a number. Infinity is not a number, so we cannot plug it in. However, I gave you before a trick. What you do is you take the biggest power in the numerator and the biggest power in the denominator, and you factor it out of every single term. You factor it out from all of the terms respectively. So for the top, the biggest power is x cubed. So what you're going to do is you're going to factor out an x cubed, and then what you're going to be left with is 1 plus 5 over x squared plus 5 over x cubed on the top. And then in the bottom, you're going to factor an x squared out. So you're going to have x squared times 3 plus 4 over 4 over x. And now what you can do is you can take the limit from the top and the limit of the bottom. So you could take limit as x goes to infinity of x cubed times 1 plus 5 over x squared plus 5 over x to the third, and divided by the limit as x goes to infinity of x squared times 3 plus 4 over x. Now, notice here that we have some cancellation happening. This x squared is going to go poof with this one, and you're just going to have an x in the top. The limit as x goes to infinity of this and this is 0, because the numerator is staying fixed, but the denominator is getting big, and they're getting big very quickly. For example, if you just make a table for x values and the output values, if x is 1, then you have 5 over 1 for both of them. If x is 2, then for the first one, you have 5 over 4, and then for the second one, you have 5 over 2. So the number is getting smaller. If you have 3 now for x, you have 5 over 9 and 5 over 3. If you have 4, then you have 5 over 16 and 5 over 4. Then when you get to 5, you have 5 over 25 and 1. And then when you get to 6, notice that now you have 5 over 36 and 5 over 6. So now these fractions are both less than 1. Now, the first one was already less than 1 after this step. But now both of them are less than 1. So both of them are eventually going to go to 0 because you keep making the fractions smaller and smaller. So in the top, what you really have is simply just x times 1. In the bottom, you have 3, and because of the same reasons as before, this 4 over x is also going to limit to 0. So what you really have is the limit of the top, which is the limit as x by itself goes to infinity, which is infinity, and the limit in the bottom, which is just 3. So this is just infinity. So this limit is infinite. Now, similarly, and notice that this you should immediately be able to tell because the degree of the numerator was equal to 3 and the degree of the denominator was equal to 2. And when the degree of the top is bigger than the degree of the bottom, we have an infinite limit. Now, if the opposite is true, if you're taking the limit as x goes to infinity of x plus 5 divided by x squared minus 3x plus 3, then this limit is actually going to be equal to 0. The reason for that is because, if we do the same process, the same steps, you take out the biggest exponent in the tops, you factor, you have x times 1 plus 5 over x divided by, this limit as x goes to infinity, divided by x squared 1 minus 3 over x plus 3 over x squared. Then for the same reasons as before, as above, this limit is going to go to 0, this limit is going to go to 0, and this limit is going to go to 0. So in the top, you're going to be left with just x over x squared, which is the same thing as 1 over x. But now when you take the limit as x goes to infinity of 1 over x, that is equal to 0 because of the previous reasons as before. The 1 is staying put, and then x is getting very big. So we see that when the denominator has a bigger exponent, the limit is 0. Now, when the degrees are equal, so when somebody tells you take the limit as x goes to infinity of something like 3x squared plus 5 and 8x squared minus 10x plus 6, if somebody tells you to take this limit as x goes to infinity, then, if you take out the biggest exponent from the biggest variable with the biggest exponent from the numerator, you're going to have 3 plus 5 over x squared divided by x squared times 8 minus 10 over x plus 6 over x squared. Limit as x goes to infinity. And for the same reasons as before, this limit is going to go to 0, this limit is going to go to 0, and this limit is going to go to 0. The x squares cancel each other out, and the only thing left is 3 divided by 8. So this limit is actually 3 over 8. Okay, 3 plus 0 is 3, and then this becomes a 1 up here, this becomes 1 up here, so 3 times 1 is 3, and 1 times 8 is 8, so you have 3 over 8 as your limit. So this is an example of a limit at infinity. We have 3 over 8, here we have 0, here we have infinity. Now, that is different from infinite limits. An infinite limit happens at the asymptotes. So, if somebody tells you, let's say, find the limit of x, as x goes to 2, let's say, of x squared minus 4 and, I don't know, let me think about this one. Let's say x squared plus 5x plus 6, that should work, x squared plus 5 plus 6, and somebody tells you to find this limit, then notice that direct substitution is not going to work, because when you plug in 2, you get some cancellation. You get the denominator is equal to 0 because 2 squared minus 4 is 0, so you cannot plug in right away. Somebody gives you a limit like this, then what you should do is factor. That's your first step, try to factor the numerator. So this numerator factors 2x plus 2 and x plus 3. The denominator is the difference of two perfect squares, so that factors as x plus 2 times x minus 2. And now you could cancel, so you have limit as x goes to 2 of x plus 3 and x minus 2. And now, you can also tell that I made this problem bad because you still have the same issue. So you know, for this particular problem, you'll have to find the limit from the left and the limit from the right and see what they are. So if somebody gave you the limit from the left for this problem, let's say, then notice that you'll be plugging in values that are less than 2. So the numerator is going to be positive, And the denominator is always going to be negative, so it's going to be negative infinity. That's going down to minus infinity. That's a bad example of my end, because it didn't work out the way I wanted it to. I mean, I guess it still worked out, but anyway, let me do another one. Let's see. So let's take the limit as x goes to 3 of x squared minus 9 and x squared plus 4x minus 21. That should work better. So yeah, for this problem, same thing. You factor, so that's going to be x plus 7 times x minus 3. Denominator again is x plus 3 times x minus 3, so it's going to work out the way that I wanted it to work out the first time. So this x minus 3 will cancel out. So you still have to take the limit as x goes to 3. But in this case, now you could actually plug in. So for this case, you could plug in 3 for x. You get 10 over 6, which is equal to 5 over 3. So for this one, we could actually find a limit. Okay, now if I gave it to you this other way, if I gave it to you as limit as x goes to 3, and instead of being that nice parabola, I just gave you x plus 7 divided by x squared minus 9 as x goes to 3, you cannot find this limit because that limit doesn't exist. Now, I could ask you for this limit from the right or from the left, but this particular limit is not going to exist because we have an asymptote at 3. The function is undefined. If you plug in 3, you get 0, so that function is undefined. So if I asked you for this, it will be something like from the left or from the right, and you have to determine whether this is going to be infinite or not. And we had various ways of doing that. You could try to do this analytically or estimating it. We definitely had different ways of doing this. So that's something that I suggest that you review. Because this left and right side of the limits, infinite limits, will come up again. And again, they happen whenever we have asymptote. So whenever you have an asymptote, you're going to have an infinite limit. I may do something like this. I may give you the graph. I don't even know if this is 7, but I'll just call it 7. Like, for example, if I give you this graph, let's say this is 3, and that's the asymptote, and it goes like this, and like this, then if I told you what is the limit as x goes to 3 of f of x, you will say does not exist because both limits are going in opposite directions. But now if I change this up a bit, and I make it both of them going down, and I ask for the same limit as x goes to 3 of f of x, instead of does not exist, here you will say minus infinity because both of them are going down to minus infinity. Now the limit, there is no limit, but we say that the limit is minus infinity. Similarly, if you have something like minus 2 here, and I have to find the limit as x goes to minus 2, of, let's call this g of x, you will say that limit is plus infinity because both the limit from the right side and the limit from the left side are plus infinity. So that's something that I also may ask you to do. So you are responsible for knowing all of these problems. As an exercise, that's an exercise to your homework problems. We had a lot of homework problems on this. Now, finally, the last few things that I said that I was gonna test you on are the derivative laws. Number one is the definition of the derivative. So if I gave you something like g of x equals 5x squared plus 2x plus 6, and I told you use the definition, the limit definition, let me be more specific, the limit definition of the derivative, to find g prime of x, what do we have? Well, we have the definition of the derivative was f prime of x is equal to f of x plus delta x minus f of x divided by delta x as limit of delta x goes to 0. So that was the definition of the derivative of function f. You could use the substitution delta x equals h. It makes your notation cleaner. So anyway, if I was asked to do this, then whenever I see an x up here, I'm going to put h. I'm actually going to use h. So I have 5x squared plus 2x plus 6. So f of x equals 5x squared plus 2x plus 6. So if I ask to find the derivative of this using the limit definition, then what you have to do is the following. You have to say, okay, wherever I see an x, I'm going to put x plus h, or delta x. So I'm going to have 5 times x plus h squared plus 2 times x plus h plus 6 minus f of x, but f of x is just 5x squared plus 2x plus 6 divided by h, and limit as h goes to 0. Okay, so now we could simplify in the top. So we have limit as h goes to 0 of 5 times x squared plus 2xh plus h squared plus 2x plus 2h plus 6 minus 5x squared minus 2x minus 6 divided by h. And there's going to be some cancellation because there's going to be 5x squared plus 10xh plus 5h squared plus 2x plus 2h plus 6 minus 5x squared minus 2x minus 6. That's simply rewriting everything here. I just rewrote it down here, and then I just distributed 5 to the trinomial. And we still haven't taken the limit, so we carry the limit notation through. And now notice that 5x squared minus 5x squared cancels out. 2x minus 2x cancels out. 6 minus 6 is going to cancel out. So we're left with limit as h goes to 0 of 10xh plus 5h squared plus 2h divided by h. Notice that every term in the numerator has an h, so we can factor an h out. So we have 10x plus 5h plus 2 divided by h. So long as h is not equal to 0, we could cancel them. So you could cancel these two h's. So limit as h goes to 0 of 10x plus 5h plus 2 is now very easy to find because now we could use direct substitution. So we have 10x plus 5 times 0 plus 2, which equals 10x plus 2. So the limit definition of the derivative can be used to find the derivative of an expression like this. Now, obviously, we also have our shortcuts like the power rule. So we could have just simply used the power rule to find this derivative quicker, because that's just 2 times 5, which is 10x. 2 minus 1 is 1. The derivative of 2x is 2, so plus 2. And the derivative of 6 is 0, so we get the exact same solution. And finally, I will ask you to know the product rule and the quotient rule. So this is a product rule, and then the quotient rule when you have something of the form f over g, and that is equal to first times the derivative of the second minus the first times the derivative of the second over second squared. I think I just said that. The second times the derivative of the first minus the first times the derivative of the second divided by the bottom squared. So this is the product rule. You need to know it. And the quotient rule. There will be no chain rule on the exam. The chain rule is going to be on the second exam though. So if you're given something like this, like f of x is equal to, let's say 3x cosine of x plus x squared, just to make it more complicated, plus x squared divided by, let's say, ln of x. Why not? Then to find f prime of x, you have to realize that you have a product. You have f times g, and then you have f, well, let me not call it f. Then you have k over, let's say, h. Here you have 4 different functions that you have to worry about. So the way that I will do this is take it piece by piece. Work first on the first piece, which is 3 times cosine of x, and then work on the second piece, which is the fraction. So the rule says for the product rule, it says the second times the derivative of the first. So it'll be cosine of x times the derivative of the first, which is just 3, plus the derivative of the second times the first. So the derivative of cosine, remember that's negative sign, so that's going to be 3x times negative sine of x. So that's for this piece. 3x cosine of x becomes all of this. And then plus the fraction that I have up here. So that's ln of x times the derivative of the top, which is 2x, minus x squared times the derivative of the bottom, which is 1 over x, divided by ln of x squared. Remember, this is what I told you, low d high minus high d low. So again, low d high minus high d low, bottom squared. And then this one is, this one, it doesn't really matter the order, but to keep it consistent, you go second times the derivative of the first plus first times the derivative of the second, because it helps you remember this rule. Because the top are the same, then you just divide by the bottom squared. But to be honest, in the product rule, the order doesn't matter. Only in the quotient rule it matters. In any case, let's simplify this because we could simplify this more. Cosine of x times 3 is simply 3 cosine of x. 3x times negative sine of x is simply negative 3x sine of x, plus 2x ln of x minus x squared divided by x cancels. One of the x's cancels, is just minus x divided by ln square of x. I can put it on the outside. Square. So this very complicated derivative boils down to, well, this very easy function boils down to this very complicated derivative. Now, in addition to this, you have to find the equation of the tangent lines. So, if I ask you to find the slope at a particular point to find the tangent line, let's say if I ask you, okay, find the equation of the tangent line for this f at the point 0, 1, then that's more work because now you have to plug in for x. So let's do it just for practice sake. If I'm plugging in into the derivative, I'm plugging in 0 for it to find the slope. So I have 3 times cosine of 0 minus 3 times 0 times sine of 0 plus, not minus, plus 2 times 0 times ln of 0 minus 0 divided by ln of 0 squared. And you may be Your instincts may tell you that ln of 0 in the denominator is going to give us an issue, but your instincts, if they tell you that, are wrong. So cosine of 0 is 1. So 3 times 1 is just going to be 3. 0 times 3 times sine of 0 is just 0. So this is minus 0, this piece. Plus 2 times 0 times ln of 0 is just 0. Minus 0 on the top divided by ln of 0 is 1. So that's just 1 squared. But because the numerator is 0, then this whole piece is 0. This whole piece is 0. So you just have 3 times 1. So that's just 3. So we have the slope is 3. So that wasn't that difficult. And now we put it together at this point. Then when we find the equation of the tangent line, we have, for y, we have 1. So y equals 1. M is 3 because that's just the slope of the derivative evaluated at the point. The derivative evaluated at the point gives us a slope. That's what I want to say. And then x1 here is 0, so this is x minus 0. So that's going to be equal to 3x plus 1. When you simplify, you get that. So that's the equation of the tangent line for this particular problem at the point 3, 1. Okay? So this is all I'm asking you to know for the first exam. There will be no questions on continuity. Okay? There will be no questions on continuity. Well, actually, I'm lying. No, that was the first quiz. No, yeah, there is a question on continuity. For continuity, let me just go over it because I just remember that it is there. For continuity, continuity is not that difficult. It all boils down to the 3 rules. A function is continuous. Just keep this in mind. A function is continuous if when you draw it, you don't have to pick up the pen. Continuity implies that the limit exists at c. So the limit exists. It implies that f of x is equal to f of c. Okay? Meaning the limit as x goes to c of f of x is equal to f of c. And by nature, it also means that f of c exists or is defined. Okay? So if all these 3 things are true, then the limit exists. Then the function is continuous. So for example, if somebody gave you the following function, 2x to the 5 minus 7x to the 4 plus 9, and they ask you, is this function continuous and on which interval? Well, this is a polynomial function. Polynomial functions are continuous in all of their domain. So this function is continuous from minus infinity to infinity. It's continuous everywhere. However, a function like the next one that I'm going to give you, a rational function like f of x equals x squared minus 3x plus 2 divided by x squared minus 1. A function like this is going to not be continuous at x equals 1 or minus 1 because if you plug in 1 or minus 1, you get 0. So an easy way to check that this is not continuous is simply do f of 1. What is f of 1? F of 1 is 1 squared minus 3 plus 2 over 0. So this is undefined, so it's not continuous. As soon as you find a point of discontinuity, the function is not continuous. Now, what if I gave this to you as a graph? What if I gave you a graph that looks like this? And let's call this point C. If I ask you, is this function continuous? You will say no, since f of c is undefined by the picture. It's not dotted in. So the graph is not continuous. Okay. Now we mentioned some removal discontinuities in this section as well. You are liable for knowing those as well. You definitely need to know what they are. I will be available for office hours for the exam. So if you have any last minute questions, please send me an email and we can certainly go over them together. Good luck on your exam, and may the odds be ever in your favor.